A little bit about what's called solids, or as the book calls them, geometric solids. And in math, when we talk about solids, we talk about three-dimensional shapes. We're talking about the shapes that give you boxes, and the shapes that give you cans. We're not talking about the pieces of paper, because those are kind of like two-dimensional. They don't really have a thickness. And we've got a couple definitions to go through here. And the first one is just a polyhedron. Polyhedron. And the word polyhedron probably comes from two different words. Poly meaning many, just like a polygon has many sides. A polyhedron, I guess the hedron part probably means many faces. Okay, but for something to be a polyhedron, it must be made up of either rectangles or squares or whatever. There are no round things on polyhedrons. And we'll get to those a little bit later. But there's no round sides, no round edges with polyhedrons. And I think you'll like this because we get to have some fun drawing some shapes today. Yay. Hopefully you'll catch on to some of the little, I'll give you some hints as to draw some nice things. Polyhedrons we're going to cut into two categories. On the left side over here, we're going to talk about prisms. Not prism, but prisms. And on the right side, we're going to talk about pyramids. Two different types of polyhedrons. And you're pretty familiar with the prisms, as well as the pyramids probably too, but what makes something a prism? Anybody know what's something that makes something a prism? Let's see what it says here. Alex?
Four vertices?
We can have more than that. You can have more than 4 vertices or 4 sides or whatever there. You can have a bunch. Okay. Prisms have to have, are shapes that have two identical, I should spell that right, two identical bases. In other words, we've got a whole bunch of different types of prisms. I'm going to blow this up a little bit here. And they would look like this. Go a little smaller here. For example, the one that you're probably most familiar with is a rectangular prism. Okay, and a rectangular prism has a rectangle, identical rectangles for both of its bases. In other words, this. I start off with a rectangle here. If I draw the same rectangle right here and connect all the corresponding vertices, it would look like this. Here, here, here. Back here you can't see them. We usually use dash lines there. Same thing for this. Usually we put dash lines back here where you can't see this. This is a rectangular prism because the two bases, for example, the ones I started with, this and this one back here that you can't see, were rectangles. Okay. You could also have a triangular prism. Guess what its bases are going to be? It's going to be a triangle. So you start with a triangle here, draw another triangle a little up and over so that you can see where the, and then you connect the corresponding bases, and you get a triangular prism there. Sometimes it helps to shade a little bit here so you can see There's maybe the front face, and then maybe over here is the back. Right side. Okay, but it has a triangle for both its bases. And you can do that with any shape. You could do it with a hexagon. Okay, kind of running out of room here. I can do it over here. A hexagonal prism. Start with the hexagon. If you can draw another identical hexagon to it over here, that would be helpful. I'm going to try. And then if you connect the corresponding vertices, there, 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 these would be dashed because they're behind, we can't see them really. Okay, if you can't draw these, they're fine, because you're going to get some sort of a gist here. Okay, that would be a hexagonal prism. Good things to try doodling with when you're bored with whatever's going on. Okay, those are prisms. And you could do that with anything. You could make it a octagonal prism. You could have a dodecahedral whatever prism. Any of those would work. You just start with those prisms there. And you could set them, well, we'll talk about that later. Now, what about pyramids, children? What is a pyramid? What makes a pyramid different from a prism? They're still polyhedrons, but what makes them different there, Andrew? They what?
There's not an identical base.
There isn't, but what is there? When you think about the pyramids of Egypt, what do they look like? Kind of, they come to a, yeah, pyramids come to a point. And they again are named for their bases. For example, I believe the Great Pyramids in Egypt, I think they are square pyramids or rectangular pyramids. Square pyramids. And I think you'll like this, pyramids. These are easier to draw really than prisms. If you start with a square pyramid, you kind of have to draw a three-dimensional square down here because we don't want to make it look like that. Here's my square. I did that because it's setting on a square. If you do that, and you put a point anywhere above it, kind of like right here in the middle, and you draw that point to all those four vertices, you get a nice looking pyramid. Again, back here would be a dashed line. And the Great Pyramids of Egypt, I believe, are in that sort of shape there, both with blocks there. You can do that. You can do that as well with a triangle. Start with the triangle. Draw a point up here. Connect your vertices. And you get this line back here. You probably wouldn't be able to see. So you make it a dashed line. You could do a little shading, I suppose. Okay, that would be your triangular prism. I don't know if that one came out the way I wanted it.
It's like a cone.
But it is. This is a triangular prism. And you could do that again, like the prisms, with any shape. If I wanted to do a hexagonal prism or pyramid, I kind of got to draw it as a squash thing. Here's my hexagonal prism pyramid. Sorry, pyramid. There's my hexagon, a little dot up there, and then I connect the points. Just like that one. Back there that you can't see. So I can draw little white lines here. And this is a hexagonal pyramid. Now let's shrink that all back down to normal size and see what we got here. You got all pyramids, you got your prisms, you got all that stuff there. A few other things that are not, these would be things that are not polyhedrons, but they're solids. Not polyhedrons, but they're solids. Not polyhedrons. And you'll see this. The first thing is a shape that looks like this. What is that?
Cone.
Yeah, a cone. It is a cone. You probably could also call that a circular pyramid, couldn't you? Okay. In addition to a cone, we have a can. What's our can called in math, Kyle?
Cylinder.
Cylinder. And the other round shape that we have, our ball shape, which is actually called a sphere. And the way that you kind of show a sphere so that it doesn't look like a circle like my thing does here is you draw this little dash kind of equator line going around kind of in an oval shape. It kind of gives it a three-dimensional kind of look. That is a sphere. So we got spheres, cones, and cylinders. Those are not polyhedrons because they do have some round sides on them. As always, we seem to have run out of time here. Now, going back to maybe draw ourselves a rectangular prism here. Because we got a couple more definitions. A couple more definitions to throw out here. And they are, we have what are called edges. We've got vertices. And we've got faces. What are edges of a shape? What are the edges of a shape? A little hard to describe. What are the edges, Kyle?
Not the corners, but the.
It's hard not to use the word to describe it, isn't it? Emma? Okay, the line where two faces meet. Line where two faces meet. Okay, so if I was pointing out the edges of this, it'd be here, 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 there, there. We got a bunch we can't see there. How many edges does this shape have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 edges of this shape. What about vertices? What are a vertice? The single of that is a vertex. A vertex. Holly?
Like point?
Yep, exactly. They're the points that you get. Or I guess you could call them corners. Okay, and those would be these. There's a corner. 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 How many corners does that shape have? How many vertices, Sam?
8.
8, I believe, is correct. And faces, another word for faces would be Faces would be what, Phil?
Sides.
Yeah, the sides. Kind of like the things that you could lay it on here. This is a face. This would be a face. This would be a face. And you can, there's 3 other faces there you can't see, for a grand total of 6 faces. 6 faces. 12 edges, 8 vertices, 6 faces. Let's take a look at a pyramid. Let's say I've got a, oh boy, let's call it a pentagonal pyramid. If I asked you to give me, let's see, this is up here. Actually, that's, well, I guess this one's not here. If you had a pentagonal pyramid there, how many vertices or how many corners do you see on this pyramid? How many corners? Kendall?
6.
6 would be correct. How many faces? How many faces? How many flat sides would it have? Alex?
7.
Well, let's see. There would be 5 going up to the point, and then just 1 on the bottom. I believe there's like 6. And then how many edges? How many edges would you get? A little tough. Caroline?
12.
I believe there's only 10.
Yeah.
Because you got the 5 on the bottom that make up the thing, and then you got the 5 coming off of all the vertices there. I think there's only 10. Is that?
Yeah.
It's a little hard to see with what I have drawn there, actually. A little hard to see what I have drawn. One more. How about a, what else could we draw? An octagonal prism? I don't know if I can do this. Oh, I know. See this, see this. Maybe I don't want How many faces would there be on an octagonal prism? Shouldn't be that hard. There's going to be 8 for all the sides that go around, and then Alex is going to be, yeah, I get 10 faces. How many vertices? How many points? 2, 4, 6, 8. Vertices, Alex says,
16.
I would say 16, and then how many edges?
7.
Yeah, they'll be there. How many edges? Answer me my last question here. You got 8 going around the sides, 8 in front, 8 in back, which would give you what? Holly? Yes, 24.
24.
Off with you now.